You have 60 years, one human lifetime. You board the fastest spacecraft we can build, point it at the stars, and go. When you're 85 years old, taking your last breath somewhere in the cosmic dark, how far from Earth will you actually be? I'm going to tell you the answer, and it's going to ruin every space movie you've ever loved, because the universe doesn't care about your dreams. It has rules, hard limits written into the fabric of reality itself. And those limits mean that even if we threw every dollar, every genius, every ounce of human willpower at the problem, most of the galaxy would still remain forever out of your reach. But here's what's going to keep you awake tonight. There's a loophole. A way to cheat the distance and reach distant stars, even galaxies, in your lifetime. Only one catch. When you arrive, everyone you've ever loved will be dead. Not just dead, dust. Their grandchildren will be dust. Centuries will have passed on Earth while you lived your 60 years in space. The universe gives you a choice. Stay close and stay connected to your own time, or go far and become a ghost, arriving in a future where you don't belong. If you're already hooked and want to support deep dives like this, there's a super thanks button below this video. Any support helps us create more content exploring these mind-bending cosmic questions. But whether you contribute or not, I'm just glad you're here for the journey. Now, if you enjoy this kind of content, go ahead and drop a like. It really helps the algorithm show this to other curious minds like yours. And consider subscribing so you don't miss what we explore next, because what I'm about to show you isn't science fiction. It's just science, and it's more brutal than any movie dared to be. Let's start with speed, because speed is literally everything. The nearest star to Earth is Proxima Centauri, 424 light-years away. That's 25 trillion miles. To reach it in 60 years, you need to travel at 7% of light speed. That's 47 million miles per hour. Sound fast? It is. It's also 109 times faster than the fastest spacecraft humanity has ever built. The Parker Solar Probe, our current speed record holder, maxes out at 430,000 miles per hour. At that speed, you'd spend 60 years traveling and cover 226 billion miles. Sounds impressive until you realize that's less than 1% of the distance to Proxima Centauri. You die having barely left the solar system. The stars would still be impossibly far away, mocking you across the void. Voyager 1, launched in 1977, has been flying for 48 years. It's 15 billion miles away, the most distant human-made object in existence. At its current speed, it would take 75,000 years to reach Proxima Centauri. 3,000 human lifetimes, one after another, and you still wouldn't be there. So you need to go faster, way faster. And this is where physics becomes your enemy. Chemical rockets are useless. To reach even 1% of light speed using rocket fuel would require more mass than exists in the observable universe. That's not an exaggeration. That's the Tsiolkovsky rocket equation doing what it does best, crushing dreams with mathematics, so we go nuclear. Project Orion, designed in the 1960s, would drop nuclear bombs out the back of your spacecraft. The explosions hit a shock plate. The force pushes you forward. Repeat thousands of times. It's insane. It's brilliant. And the math says it could reach 3% to 5% of light speed. At 5%, Proxima Centauri is 85 years away. Close. Agonizingly close to a single lifetime. If you launched at age 20 and lived to 105, you'd barely make it. That's your first realistic answer. With nuclear pulse propulsion, technology we could build today if we chose to, you could potentially reach the nearest star. Maybe, if everything went perfectly, if you lived long enough. But let me tell you what that journey actually looks like. 3 days of crushing acceleration. 2.5 gs pressing you into your bunk. You can barely breathe. Every movement is exhausting. Your bones ache. Your chest feels crushed. Then the bombs stop. Silence. You're coasting at 34 million miles per hour through absolute emptiness. For the next 85 years, your spacecraft is tiny. Maybe 50 square meters, that's a small apartment. That's your entire world. Same walls, same recycled air, same 30 freeze-dried meals in rotation. You'll eat each of them 1,000 times. You have windows. Through them, stars, just stars. Unchanging points of light against infinite black. Earth vanishes behind you within months, a pale dot swallowed by the sun's glare. You're alone, more alone than any human being has ever been. You message Earth. You pour your heart out in videos and emails. The reply delay grows. 6 months, a year, 2 years, 5 years. By year 20, your messages take 8 years to reach home. By year 40, 16 years. The people you're talking to age decades between your question and their answer. They move on, they have to. You're a voice from the past, growing fainter with every light year. Around year 30, something breaks inside you. Maybe it's the isolation. Maybe it's the cosmic rays that have been sleeting through your body for 3 decades, shredding your DNA, seeding cancers that will kill you slowly. Maybe it's just the crushing weight of realizing you'll never feel wind again, never smell rain, never touch another human being. We don't know what 60 years of isolation does to a human mind because we've never tried it. You're the experiment. And somewhere in that 3rd decade, you discover whether humans are actually built for this. If you want to go faster, you need fusion. Fusing hydrogen atoms releases 8 times more energy than splitting uranium. With fusion propulsion, you could reach 10% of light speed. Maybe 20% if the engineering works perfectly. At 10%, Proxima Centauri is 42 years away. At 20%, just 21 years. Now we're talking. Now you could reach multiple stars in one lifetime. Launch at 25, arrive at Proxima at 46, spend 10 years exploring, push on to Barnard's star at 76. 2 alien star systems before you die. At 20% of light speed, you can cover 12 light years in 60 years. That gives you access to maybe 30 or 40 star systems. Proxima, Barnard's star, Wolf 359, Sirius, Tau Ceti, real places, some with planets, some possibly with life, but fusion propulsion doesn't exist yet. We've been trying to build fusion reactors for 70 years. We're close, maybe decades away from power plants, probably a century away from rocket engines. So 20% of light speed is a maybe, a hopeful maybe, but not today. Here's your realistic answer with technology we might build in the next 50 to 100 years. 10 to 20 light years, 3 or 4 dozen star systems, out of 400 billion in our galaxy. The Milky Way is 100,000 light years across. A 20 light year reaches 0, 25% of the galaxy. The rest, all of it, every other star, every other world, forever out of reach. You could spend your entire life traveling and die having seen only your immediate cosmic neighborhood, Unless you're willing to pay the price, because there's a way to go farther, much farther, and this is where everything changes. Einstein's special relativity tells us that time is not absolute. The faster you move, the slower your clock ticks compared to the rest of the universe. At low speeds, the effect is tiny. At 10% of light speed, your clock runs 0, 5% slower than Earth's, barely noticeable. At 20%, about 2% slower, still small, but watch what happens when we go faster. At 50% of light speed, your clock runs 15% slower. 60 years for you equals 69 years on Earth. At 70%, time slows to 60% of normal. 60 years for you, 84 on Earth. A full generation passes while you live your life. At 86% of light speed, time runs at half speed for you. 60 years for you, 120 on Earth. Everyone you knew is gone. At 90% of light speed, you experience 60 years while 137 years pass on Earth. You leave in 2026. You arrive in 2163. At 99%, 425 years pass on Earth. You arrive in the 25th century. Civilizations have risen and fallen. Every single person alive when you left is dead. Their children are dead. Their grandchildren's grandchildren are old or gone. This is time dilation. It's not theoretical. It's measured reality. GPS satellites account for it or they'd be useless. Atomic clocks on airplanes tick slower than clocks on the ground. Particles in accelerators live longer when moving fast than when stationary. This is real physics, as real as gravity, and it means you can travel far in your lifetime, incredibly far. At 99% of light speed, you could reach stars 60 light years away in your 60 years of subjective time. At 99.9%, you could travel hundreds of light years while thousands of years pass on Earth. At 99.99%, you could cross to the other side of the galaxy. Get close enough to light speed and you could theoretically reach Andromeda, 25 million light years away in a single human lifetime. You'd age 60 years. The universe would age 25 million. The sun would be dead, Earth would be frozen or vaporized. Humanity would be evolved beyond recognition or extinct. You could visit distant galaxies. You could see wonders no human has imagined. You could explore the cosmos in your one precious lifetime. But when you arrived, you'd be arriving in a future where nothing you knew existed anymore. You'd be a time traveler, a ghost, unable to return home not because of distance but because home in your time no longer exists. The universe is offering you a deal. I can show you distant galaxies. I can take you to the edge of creation. I can let you see things no one from your era will ever witness. All you have to do is give up everyone you love, give up your entire civilization, give up your time itself. Walk away from everything that anchors you to humanity and accept that you'll arrive in a future where you're the last remnant of a dead past. Would you take that deal? Drop your answer in the comments right now, because this isn't hypothetical. This is the actual choice facing anyone who wants to travel far through space. Connection or distance, home or exploration, you cannot have both. Most people, when they really understand this, say no. They'd rather stay in their own time, even if it means never seeing distant stars. They'd rather die having traveled 10 light years than live to see Andromeda but lose everyone they love. And that tells you something profound about humans. We're a social species. We're wired for connection. The stars are beautiful and mysterious and worth exploring, but not at the cost of everything that makes us human. So here's the final answer. How far can a human actually travel through space in one lifetime? It depends on what you're willing to lose. If you want to stay connected to Earth, to your own time, to the possibility of home even if you never return, you can reach about 10 to 20 light years with realistic near-future technology. That's a few dozen star systems, enough to search for life. Enough to establish humanity's first interstellar presence, enough to matter. If you're willing to embrace time dilation, to accept that you're traveling into the future and everyone you know will be gone, you can go much farther, hundreds of light years, thousands. You can explore vast regions of the galaxy, visiting world after world, seeing wonders beyond imagination. The universe puts no limit on how far you can go if you're willing to pay the price in time, but here's what I think the real answer is. The real answer isn't about the distance, it's about what you're traveling for. Because even 20 light years, even one nearby star, even Proxima Centauri alone would be enough to change everything we know. One planet orbiting one other star could answer the oldest question humanity has ever asked. Are we alone? You don't need to visit a million stars to find meaning. You need to visit one, the right one, the one with life, the one with answers. The one that proves we're part of something larger, and that might be within reach. Proxima Centauri has a planet in its habitable zone. We don't know if it has water, we don't know if it has life, but it could. And finding out would take 42 years at 10% of light speed. One lifetime, your lifetime, that's the opportunity, not to explore everything, not to visit every star, but to reach one, to take the first step, to prove it can be done, and after you, others will follow. Generation after generation, reaching farther, building on what you started, one star at a time, over centuries. That's how humanity spreads. The universe is 93 billion light years across. You can reach maybe 20 of those light years. That's not a failure, that's not a limitation, that's a beginning. Because the alternative is staying on Earth, never leaving, never trying, dying on the same world where you were born, wondering what was out there, wondering if we're alone, wondering if the stars are really unreachable or if we just weren't brave enough to find out. Every great journey in human history started with someone deciding the horizon was worth reaching even if they didn't know what was beyond it, even if the journey was dangerous, even if they might not survive. They went anyway, and some of them changed everything. Interstellar travel is our next horizon. It's harder than any journey humans have ever attempted. The distances are staggering, the technology barely exists, the risks are existential, but the horizon is there, the nearest stars are there, within reach. Within one human lifetime, if we build the right spacecraft and find the right people willing to go. So when I ask how far you could travel through space in one lifetime, the scientific answer is 10 to 20 light years without time dilation, or functionally unlimited distance if you're willing to lose your own time. But the real answer is simpler. You could go as far as your courage takes you, as far as your willingness to sacrifice, to endure, to push beyond every limit can carry you. The universe has set boundaries, the speed of light, the flow of time. These are hard limits, unchangeable, built into reality itself. But within those limits there's room to explore, room to discover, room to reach beyond our world and touch other worlds orbiting other suns. 60 years is not long enough to cross the galaxy. It's not long enough to see everything or answer every question. But it's long enough to start, it's long enough to reach the nearest stars. It's long enough to search for life. It's long enough to matter, and maybe that's enough. Maybe the point isn't conquering the cosmos. Maybe the point is taking the first step and proving it can be done. Maybe the point is being the generation that reached beyond Earth and touched another star, even if it's just one, even if it takes everything we have. Because once we've done it once we've proven that humans can travel to other stars and survive, the rest becomes inevitable. Not in our lifetime, not quickly, but eventually, one star at a time, one world at a time. Until the descendants of that first mission, hundreds of generations from now, look up at a sky full of human civilizations scattered across dozens of stars. And it starts with you, with your choice. With your willingness to ask how far we can go and then actually try to get there. The stars are waiting. Some of them are within reach, not all, not most, but some. And sometimes some is enough. If this changed how you see space exploration, if you're thinking about these questions differently now, hit that subscribe button. We're diving deep into the cosmic mysteries that most channels won't touch. And if you'd like to directly support the research and production that goes into videos like this, the super thanks option below is a wonderful way to help us keep creating this kind of content. But honestly, just being here and engaging means the world. Now tell me in the comments, if you could board a spacecraft today, knowing you'd reach another star but never return to Earth, would you go? There's no wrong answer, just yours. Thanks for taking this journey with me. Keep looking up. The stars might be distant, but they're not completely unreachable, and that changes everything.